safety boots or steel cap shoes, overalls, and heavy-duty insulating gloves. The working area must be clean, clear of all obstructions at all times, and recognize safe working practices must be observed strictly at all times. Video Manuals offers a series of technical videos for the bike enthusiast. This video presents the disassembly and reassembly of a late-model Harley-Davidson forward constant mesh 5-speed transmission. This particular 5-speed transmission was released from the factory in the spring of 1993. The side of the transmission facing towards the bottom we'll call the clutch side. The side to the right of your screen is the front and faces your motor. The side to the left of your screen is the rear and faces towards your rear tire. The side facing directly towards you is the top of the transmission, and the side facing towards the upper part of your screen with the shaft coming out of it is called the primary side. This shaft is referred to as the main shaft, which via a tooth belt or chain delivers the raw power from your motor to your rear wheel. Now that the oil has already been drained from the case, let's commence the disassembly. Making sure our transmission is stable on the bench, we'll remove the top cover by undoing the following 5/4 inch by 20 UNC cap screws using a 3/16 inch Allen wrench. Once all the cap screws are removed, we carefully lift the top cover, moving it side to side to clear any obstructions. Here on the inside left of our top cover plate, we have the switch for the neutral indicator. Using a 3/16 inch Allen wrench, we remove the 2/4 inch by 20 UNC cap screws in each pillar block. Once we have removed all 4 1/4 inch cap screws from the pillar blocks, we lift the selector arm paw like so, and lift the whole shift drum assembly out of the transmission, making sure to clear the 2 locating dowels on the clutch side. Take notice of all the intricate grooves in the shift drum. The dogs from the selector forks ride in these grooves. This pillar block will just pull off the end of the shifter drum shaft. In the center of this pillar block, we find a needle roller bearing, which has been mounted permanently in this pillar block. You must be wearing your safety glasses before you proceed any further. With the second pillar block, we take a pair of circlip pliers and insert the small nipples into the 2 holes on the circlip. We carefully remove the circlip. Taking a small flat blade screwdriver, we break the surface tension between the washer and the machine surface. Now the washer will slide off, and then the pillar block itself. On this particular pillar block, we have a similar needle roller bearing to the first pillar block, plus there is a spring-loaded pin or dog. This pin is referred to as a detent pin. As you can see, the ends of the shifter drum are very different. Here on the left-hand side of the shifter drum, we have the cams, over which the detent pin slides and locks the shifter drum in place. And here is where the selector paw arm grabs the shift drum pins to change the position of the shifter drum. Turning the transmission to face the clutch side, we find the ball and ramp housing. Taking a 3/16 inch Allen wrench, we need to remove these 6/4 inch by 20 UNC cap screws. Holding the housing, we remove the last of the cap screws. Then pulling the housing away, we find the ball and ramp assembly itself and a dipstick. Still wearing our safety glasses, we use a pair of straight circlip pliers to remove the large circlip which holds the ball and ramp assembly in place. Be careful, as this is a very strong circlip and could fly off the end of our pliers at any time. Once the circlip is removed, we take the top plate out. There are 3 ramps underneath this plate. These ramps sit on top of these 3/4 inch diameter ball bearings. Now we remove the 3 ball bearings themselves, and then the base plate. The base plate also has 3 ramps which correspond directly to the top plate. We use a 5/16 inch Allen wrench to loosen the filler or dipstick and finally remove it from the ball and ramp housing, leaving the housing completely bare. The purpose of this dipstick is to give us an indication of the oil level in our transmission case, which should be checked as frequently as your engine oil. Grabbing the clutch rod assembly, we're able to remove it from the main shaft. Be forewarned, the circlip we're about to remove can fly off in any direction, therefore you must wear safety glasses. Using a pair of needle nose pliers and a small flat blade screwdriver, we remove the small circlip. After the circlip comes a thrust washer. Then comes the linear thrust bearing, which allows the clutch rod assembly to rotate when the ball and ramp activates the clutch rod assembly to disengage the clutch, and then we remove the second thrust washer behind the linear bearing. Not all clutch rod assemblies will have this metal umbrella as seen here. In place of the metal umbrella, there would simply be a small flange behind the second thrust washer. Turning the clutch rod assembly around, we can see this flange behind the umbrella. Turning the transmission to the primary drive side, we locate the threaded plug for the shifter fork shaft. Once located, we take a 1/4-inch ball end Allen wrench, we firmly twist the plug to break the thread locking compound, and remove the shifter fork shaft plug from the transmission case. Then we use the ball end of our Allen wrench to push the shifter fork shaft back through the 3 shifter forks, twisting the shifter fork shaft from the clutch side as we push with the Allen wrench. Gently rest each shifter fork on the gears as the shaft passes through them, so that you don't run any chance of damaging either the shifter forks or the gears themselves. We remove the shifter fork shaft completely from the transmission. Now we remove each of the 3 shifter forks from their respective gears. Placing a screwdriver in the shifter fork groove, we move one of the gears on the lay shaft across so that its dogs lock with those of another gear. We do the same to one of the gears on the main shaft. Do not use your fingers. At the same time, we rotate the main shaft until both the main shaft and lay shaft lock together. Now that both shafts are locked together, we move to the face of the trap door. Holding the transmission, we take a 1 1/16" hex socket and loosen the Nylex nuts at the end of both shafts. We do not remove these Nylex nuts at this stage. Using our 1/4-inch Allen wrench, we remove the 4 5/16 by 18 UNC cap screws that line the bottom of the trap door. Taking our 3/16" Allen wrench, we remove the 2 remaining 1/4-inch by 20 UNC cap screws from the top of the trap door. We now take a soft hammer and firmly strike the main shaft several times. Then, going back to the trap door, we use a flat blade screwdriver, only in the special recesses provided, to pry the trap door gently free of the transmission case. Both the main shaft, the lay shaft, and trap door should all slide out as one unit, leaving the final or main drive gear in the transmission case. Here, we can see the complete configuration of the gear cluster. The main drive gear, which is the 5th top gear of this transmission, has remained in the case. To your right of the main drive gear is the lay shaft bearing. Turning the clutch side of the transmission to face the bench, we locate the main drive gear shaft on the primary side. Before we can remove the main drive gear, we must first remove the hardened spacer and its O-ring from the shaft of the main drive gear. Now we take our rubber mallet and firmly strike the shaft of the main side gear. With our other hand, we support the main drive gear from inside the transmission case as we hammer it out of the transmission case. Once we have the main drive gear out of the case, we quickly inspect it for any cracks or chips before placing it on the bench. Using a large flat blade screwdriver to slip between the 5th oil seal and the main shaft bearing, we lever the main shaft oil seal up and out of the transmission case. Do not reuse any of the circlips, O-rings, seals, and bearings you have removed from your transmission. Taking a large pair of offset circlip pliers, we remove the main shaft bearing circlip. This will require a bit of effort as this circlip is extremely strong and difficult to compress. The main shaft bearing will remain in the transmission case for now. Using a 5/8" ring or box wrench, we back off the lock nut on the adjuster for the selector arm. With a 1/4-inch Allen wrench, we take the selector arm adjuster out of the transmission case. Note the way the pin at the end of the adjuster works the selector arm back and forth as we remove the selector arm adjuster. Taking a pair of offset circlip pliers, we remove the circlip on the selector arm shaft. We use a screwdriver to break the surface tension between the washer and the transmission case, so that we can easily grab the washer and take it off the selector shaft. Once we've stabilized our transmission case, we push the selector arm shaft back through its oil seal and into the transmission case, removing the selector arm assembly. And here we have the complete assembly. To remove the selector arm paw, we take a pair of circlip pliers and remove the circlip and the two small washers from the pivot pin. These two washers actually act as spacers to align the selector paw with the pins on the end of the shifter drum. Peeling the selector paw spring back, we remove the selector arm paw. The pins at the end of the shifter drum sit between these two jaws. Now we are left with the pivot pin and spring, which should be removed next. Moving to our press, we place the selector arm assembly on a pair of parallels in our press. We check that the spring is not caught between the selector arm plate and the parallels. We then press the pivot pin out. If you do not have a press available, you can set up your selector arm assembly in the jaws of a bench vise in a similar manner as shown, and gently tap it out with a steel hammer. Both the pivot pin and the spring should be discarded, as they cannot and should not be reused. Back to the primary side of our transmission case, we use a flat blade screwdriver to remove the old seal for selector arm shaft. Using a pair of multi-grip pliers, we remove the two locating dowels on top of the transmission. Both of these dowels are to be discarded. Taking our 1 1/16 inch hex socket and ratchet, we remove the Nylex nut on the main shaft. Behind the Nylex nut, we find a washer. Using a small flat screwdriver, we can bring the washer forward and off the main shaft. The procedure is exactly the same for the Nylex nut and washer on the lathe shaft. Using a rubber mallet, we firmly strike the end of the main and lathe shafts, making sure we strike the end of the respective shafts and not the trapdoor itself. Under no circumstances, use a steel hammer, as it will permanently damage the trapdoor. We also alternate between striking the main shaft and the lathe shaft, the reason being we want both shafts to move out of the trapdoor bearings at the same rate, thus avoiding any of the gears smashing into one another. After several alternating blows, both the main shaft and the lathe shaft will slip away from the trapdoor bearings, leaving us with just two circlips and two bearings remaining in the trapdoor. This is our lathe shaft or counter shaft. We remove the dome-shaped spacer, taking note that this spacer has a completely flat rear face. Fourth gear just slides off the splines on the trapdoor side of the lathe shaft. We suggest that you mark your gears like this as you remove them. First gear slides over the splines on the trapdoor side of our lathe shaft. Note that on this gear, the thrust washer has been built into its design. Spreading the split cage needle bearings like so, we slide it over the splines of our lathe shaft. Next, we remove the thrust washer, also sliding it off the trapdoor side. Using our snap ring pliers, we spread the snap ring sufficiently to clear the spline and carefully pull it off the trapdoor side of the lathe shaft, being careful not to damage the splines as we go. Now, third gear will easily slide off the splines of the trapdoor side of the lathe shaft. To remove the remaining two gears, we rotate the lathe shaft to the primary side. Using our snap ring pliers, we remove the third snap ring here in front of fifth gear. Fifth gear now slides off the splines on the primary side of the lathe shaft. Second gear will also follow the fifth gear and slip off the primary side of the lathe shaft. Under second gear, we find our second split cage needle bearing. This split cage bearing is removed in the same manner as the earlier split cage bearing. Sliding the fourth thrust washer off the lathe shaft, we are left with one snap ring. Using our snap ring pliers, we will slip it off the primary side of our lathe shaft. We are now left with the bare lathe shaft. Don't forget, the dark end or the threaded end is the trapdoor side and the other end is the primary side. From the trapdoor side of our main shaft, we remove the dome-shaped spacer. Note this spacer has a lip or shoulder on its flat face. Fourth gear slips off the trapdoor end of the main shaft. In the bore of our fourth gear, we find a split cage needle bearing. We use our finger to pry it out. Next, we slide off the thrust washer for fourth gear. Taking a pair of snap ring pliers, we carefully slide the snap ring over the splines and off the shaft. Note that first gear has a groove for a shifter fork. First gear will slide off the trapdoor end of our shaft. Using snap ring pliers, we remove the snap ring for first gear. Behind the snap ring, we find another thrust washer. It is interesting to note that all of the thrust washers in this 5-speed transmission are the same size. Third gear will slide off the trapdoor side of our main shaft, leaving us with a split cage needle bearing. Prying this split cage needle bearing apart, we're able to slide it gently over and off of our main shaft. Second gear will slide off the primary side. Note second gear also has a groove for a shifter fork. We are now left with one thrust washer and one snap ring, which we will remove straight away. Now completely stripped, you can plainly see the configuration of the main shaft. To press out our main drive gear bearing, we must select an arbor that will clear the shoulder on the inside of our tranny but catch the main shaft bearing itself. There is no internal shoulder for the lay shaft, therefore it only needs to clear the transmission case itself. The main shaft bearing can only be pressed out from inside the case. Making sure we clear the internal shoulder, we gently increase the pressure until the main shaft bearing is forced out. Again, if we don't have a press available, we use a soft hammer on the arbor and gently tap the bearing out of the case. At the back of the main shaft bearing housing, we can see the shoulder where our bearing was seated against. After having moved the transmission case, we must ensure that it is once again level, and then placing the arbor we've selected on our lay shaft bearing, we gently apply pressure until the lay shaft bearing is forced through the case. We watch the arbor closely to ensure it does not come in contact with the transmission case at any stage. Finally, the lay shaft bearing and the arbor will fall into our hand. With a pair of offset circlip pliers, we remove both circlips from each of the trapdoor bearings. Very important, these circlips must be removed before attempting to press the trapdoor bearings out. Once again, we select an arbor that will clear the internal shoulders in the trapdoor and make as much contact as possible with the trapdoor bearings. Facing the clutch side of the trapdoor down, we place our arbor on the trapdoor bearing. Making sure we clear the shoulder, we press both trapdoor bearings out. Note that the procedure we used here is the same one that we use for the main gear drive bearing removal, in that each of them can only be pressed out from the inside. After letting our transmission case soak in our solvent tank for approximately 10 to 20 minutes, we use the flat edge of our 6-inch rule to scrape the old gasket material away. To avoid scratching or damaging the soft aluminum gasket surface, we do not use knives or anything with sharp edges. Being patient, we scrape away and remove all traces of the old gasket and gasket sealant. A small paint scraper is ideal for this job. Be sure that you wear rubber gloves and safety glasses and that your solvent tank is in a well-ventilated area. The stock 5-speed transmission case is on the left side of your screen. The case on the right is the Sputh 5-speed case for 4-speed frames. The trapdoor screw-hole configuration is exactly the same as the stock 5-speed on the left. The top of both cases are again the same, both in physical size and configuration, allowing us to use the stock top cover plate. Turning to the primary side, we see a dramatic difference in shape and size. The difference is where and how each transmission case mounts to its respective primary case. Plus, the stock transmission case uses a larger main shaft bearing than the Sputh case. Here on the bottom of the cases, we can see a startling difference in how each transmission is mounted in their respective frames. Plus, the position of the oil drain is also different. These are the two bearings we need to install into our Sputh case. The part number for the Sputh main drive gear bearing is 8233. The Sputh lay shaft part number is 8511. Before using our outside micrometers, we must check that our outside mics are zeroed by placing their respective anvils firmly in the outside micrometers like so. The 0 on the drum must line up with the horizontal line on the horizontal scale. The procedure for setting the 1 to 2 inch outside micrometer is exactly the same as the 3 to 4 inch mic, except we use the 1 to 2 inch anvil. After setting the internal bore gauge at 2.95 inches with our outside micrometer, we place it in the main shaft bearing housing. Holding the bore gauge at 90 degrees, we check the housing diameter in 3 or 4 different positions. This will also show us how round the bearing housing is. The bearing housing diameter is 2.9507 to 2.9519 inches plus or minus nothing. Next, we check the main drive gear bearing we intend to use. The sputhe bearing diameter should be 2.9507 to 2.9519 inches plus or minus nothing. The stock main drive gear bearing diameter should be 3.346 inches plus 0.5 of a thou minus nothing. We check the lay shaft bearing the same way. Double-check your measurements in different positions around the bearing circumference. The sputhe lay shaft diameter should be 0.985 plus nothing minus 1 thou. To insert the main shaft bearing, we must freeze it in the freezer for at least 20 minutes and heat the transmission case at 350 degrees Fahrenheit for approximately 10 to 15 minutes. You must wear a pair of heavy-duty industrial leather gloves to handle the hot transmission case and the frozen main shaft bearing. Placing the hot case on a piece of steel, we quickly take the frozen main shaft bearing and simply line it up with the bearing housing and push it down into the bearing housing like so, until it's seated squarely against the shoulder. Next, we check the trapdoor bearings and trapdoor bearing housing tolerances as we did for the main shaft bearing and housing, using our outside micrometer and our bore gauge. The trapdoor bearings diameter should be 1.851 inches plus 0.5 of a thou minus nothing. The trapdoor housing diameters should be 1.849 inches plus nothing minus 0.5 of a thou. Once again, we must take 3 or 4 different measurements from different positions around the bearing housing circumference. Both trapdoor bearings are to be pressed in, so we select an arbor that will contact the bearing on the outer race only and clear the bearing housing at the same time. You must not use the inner race of these bearings to press them in with. If you do, you will damage the bearing. Placing the trapdoor in our press, we line the trapdoor bearing up so that it is seated squarely in the trapdoor bearing housing. We gently press the trapdoor bearing into its housing until it is seated squarely against the shoulder of the bearing housing, and the other trapdoor bearing is inserted in exactly the same way. Using an arbor and exactly the same procedures we have just demonstrated, the lay shaft bearing has already been pressed until it is flush with the outside of the transmission case. The trapdoor we are rebuilding is different to the stock trapdoor we removed earlier. The sputhe trapdoor is a solid billet of high-grade 60-61 T6 aluminum and would be used in high-performance bikes. Otherwise, the hole pattern and locating dowels are exactly the same. The sputhe trapdoor is not relieved as the stock trapdoor, making the sputhe trapdoor extremely strong and able to handle forces far in excess of the stock application. If your circlips have a bevel on one side, like this circlip, the bevel must face away from the bearing when installed. Before inserting the circlips into the trapdoor, we must make sure that the trapdoor bearings have cleared the circlip recess in both housings and that there are no other obstructions. Wearing our safety glasses, we take our circlip pliers and compress a circlip. Making sure the circlip pliers firmly grip the circlip, we carefully slide it into position. These circlips will keep the trapdoor bearings in the correct position. And as always, make sure that you are wearing your safety glasses. At the bottom of the screen is the stock belt drive main shaft we removed from our earlier stock 5-speed transmission, and above it is the chain drive main shaft that we will be using to build this high-performance 5-speed transmission for a 4-speed frame. Here we can see all the main shafts and lay shafts made for stock 5-speed transmission. We will be using Andrews shafts and gears to rebuild this high-performance transmission. Andrews replacement shafts are made from high-nickel steel with aircraft-quality heat treatments from the top down. Number 1, 1981 to 1984 chain drive main shaft. Andrews part number 296800, stock part number 35042-79, overall length 12.065 inches. Number 2, 1985 to 1989 belt drive main shaft. Andrews part number 296850, stock part number 35042-85, length 14 inches. Number 3, 1990 only belt drive main shaft. Andrews part number 296900, stock part number 35042-91, length 13.605 inches. Number 4, 1991 and up belt drive main shaft. Andrews part number 296910, stock part number 35042-91, length 13.605 inches. Number 5, 1984 and up lay shaft. Andrews part number 296700, stock part number 35632-79, length 8.11 inches. Before assembling our main shaft, both bearing surface diameters are to be 1.023 inches diameter plus 0.5 of a thou minus nothing. Where the main shaft passes through the main shaft bearing, the shaft diameter is to be 1 inch plus nothing minus 1 thou. The trapdoor bearing surface diameter is to be 0.787 inches plus 1 thou minus nothing. The snap ring groove width is to be 70 thou plus 1 thou minus nothing. We now take a new snap ring, stock part number 8104, sputh part number 11067. Once we're satisfied that the main shaft is within all tolerances, on from the primary side of our main shaft, we use a pair of snap ring pliers to slip the snap ring over the splines into the first snap ring groove. Then we make sure that the snap ring is completely in its groove. Under no circumstances do we use any snap ring, circlips, or thrust washers. From the trapdoor end of our main shaft, we slide on a new thrust washer, part number 8109, all the way up to the snap ring. Next, we need a new split gauge needle bearing, stock part number 8876A, sputh part number 8102. Before we install the split gauge needle bearing, we apply a light smear of assembly lube to the bearing surface. Our split gauge needle bearing is installed from the trapdoor side of the main shaft, being careful not to spread it any further than necessary to slide it over the splines. Third gear for the main shaft, Andrews part number AP3M2C, stock number 79A, slides on from the trapdoor side of the main shaft with the 5 dogs facing the primary side of the main shaft. We spin third gear to make sure it will rotate freely on the split gauge needle bearing. We slide another new thrust washer over the trapdoor end of the main shaft until we have the thrust washer firmly against third gear, leaving the snap ring groove clear. The new snap ring will also slide on from the trapdoor side of the main shaft. Spreading the snap ring with our pliers, we bring it up as close as we can to the snap ring groove. Using the jaws of our pliers, we make sure the new snap ring is completely in the groove and off the splines. The clearance between third gear and the thrust washer should be 0.15 of an inch. This clearance is the same for all the thrust washers throughout the transmission. Now rotating second gear, the shaft, Andrews part number 2M3C, slips on from the primary side of the main shaft, making sure that the groove for the shifter fork is facing toward the trapdoor end. Here we have Andrews chain drive fifth gear. For a chain drive transmission, Andrews part number AP5CH. With both the stock belt and the Andrews chain drive fifth gear side by side, we can see the main difference is the spline on the rear of the main drive shafts, the fine splines for the belt drive and coarse splines for the chain drive sprockets respectively. Fifth gear slides on from the primary side of the main shaft with the drive sprocket end of the fifth gear facing towards the primary. First gear, Andrews part number A2-94, also has the groove to accept a shifter fork. Now, first gear goes on from the trapdoor end of the main shaft with its beveled drive dogs facing towards the trapdoor. With first gear firmly up against third gear, we take another new snap ring, and with our snap ring pliers, ease it over the trapdoor end of the main shaft and into its groove. Then we place a new thrust washer up against the snap ring we just installed. Placing a smear of assembly lube around the bearing surface for the split gauge needle bearing, we take a new split bearing, sputh part number 8102, stock part number 8876A. Fourth gear, Andrews part number AP4M, slides on the trapdoor end of our main shaft and over the split gauge needle bearing. We turn fourth gear back and forth to ensure it will rotate freely. Finally, we take our dome spacer, making sure we select the spacer with the lip or shoulder on the flat face. The spacer slips on from the trapdoor side of the main shaft, the flat face toward first gear. We have now completed the main shaft assembly. Take the time to check that your assembly is the same as you see here. Here we have the lay shaft that we are going to use in our new 5-speed Sputh transmission. At the bottom of your screen we have the stock lay shaft we removed earlier from our stock 5-speed transmission. As you can see, the Sputh lay shaft here is slightly shorter than the stock shaft. To use a stock lay shaft in the Sputh 5-speed transmission case, we have to shorten it by 1/4 inch or 250 thou on the bearing end only. Before we start grinding, we must confirm the overall length of the stock shaft to be 8.11 inches with our dial vernia. The overall length specified by Sputh Engineering for their transmission case is 7.86 inches. This translates to grinding 250 thou or 1/4 inch off the bearing surface at the end of our lay shaft. Using our dial vernia, we put a few indicator marks on our lay shaft so that we can see when we are approaching the right length. The stock bearing surface length is 1 inch. We place our indicator marks at approximately 0.8 of an inch from the splines in several different positions around the circumference. Placing the lay shaft squarely against the grinding wheel, we rotate the shaft. Every few seconds, we dip the lay shaft in some water to keep it cool. Under no circumstances, let the shaft get hot. We frequently check the length of our bearing surface. Once we reach the indicator marks, we check the overall length of the shaft every few seconds. Once we've reached the desired length of 7.86 inches, we dress the end of the lay shaft to remove the sharp edge. Taking a new snap ring, we slide it over the primary end of the lay shaft. With our snap ring pliers, we place it in the second snap ring groove. We then place a new thrust washer on the primary side of this snap ring. We apply some assembly lube to the split cage needle bearing surface. The new split cage needle bearing also slides on from the primary side of the lay shaft. Second gear, Andrew's part number AP3M2C, is placed firmly against this thrust washer from the primary side with its dogs facing the trapdoor side of the lay shaft. We rotate second gear to ensure it is seated properly on the bearing. Fifth gear, Andrew's part number AP5C fits flush up against the primary side of second gear. Then we use a new snap ring, Sputh part number 11067, stock part number 8104, to hold fifth gear and second gear in position. Third gear, Andrew's part number 2M3C. This is the only gear with a shifting fork groove on the lay shaft. Third gear slides on from the trapdoor end of the lay shaft with the shifting fork groove facing towards second gear. We slide a new snap ring over the lay shaft and up to the snap ring groove closest to third gear. Then we slide a new thrust washer up to the trapdoor side of the snap ring. Again, we apply a light coating of assembly lube to the split cage needle bearing surface. We slide the new split cage needle bearing over the trapdoor end of the lay shaft and into position. First gear, Andrew's part number AP2-94, will slip on from the trapdoor side as well. The shoulder of fourth gear, Andrew's part number AP4C, is actually a spacer designed to hold fourth gear, a specific distance from first gear. The shoulder of fourth gear fits up against the shoulder of first gear like so. Finally, we take our remaining dome-shaped spacer without the lip and place it up against fourth gear. This completes the assembly of the lay shaft. Take a few moments to check that all the gears are installed correctly. It is very important that we use only new snap rings and thrust washers, seals, bearings, and circlips when rebuilding any transmission. All the snap rings and thrust washers used both on the lay shaft and the main shaft are the same size. The pivot pin of the selector arm has a step diameter. The diameter of this section is 330 thou and presses into the shifter arm. The circlip end is 0.324 inches in diameter and passes through the shifter arm assembly. We need to have 250 thou, or 1/4 inch, between the head of the pivot pin and the selector arm. Taking the selector paw spring, we can see that it has two different size hoops. The small hoop of the spring fits onto the shifter arm assembly. The pivot pin slides through the spring from the selector arm shaft side only and into the selector arm assembly. Taking the selector arm mechanism to the press and placing it on our parallel, we press the pivot pin into the selector arm, making sure we do not crimp the spring. If we did not have access to a press, we would place the selector arm mechanism in a set of vice jaws and gently tap the pivot pin into position with a hammer. Remember, we have to leave 0.25 inches between the head of the pivot pin and the selector arm. We check this with our dial verniers by inserting the reverse jaws of our vernier between the head of the pin and body of the selector assembly. We place the shifter paw on the pivot pin with the jaws facing towards the selector arm assembly, the larger end of the spring slipping onto the back of the shifter paw. Holding the shifter paw in position, we place two washers, part number 8324, on the pivot pin, followed by a small circlip, part number 8335. Using the circlip pliers, we make certain that the circlip is seated securely in its recess on the pivot pin. After installing the circlip, we move the shifter paw back and forth to make sure that it moves freely on the pivot. To replace the selector arm assembly in the transmission case, we will need the following: a small arbor, a pair of offset circlip pliers, a circlip, a retaining washer, a seal, the selector arm assembly, of course, and a soft hammer. The open end of the oil seal must face in towards the transmission case. Note there is a small spring inside the oil seal. Placing our seal squarely in the transmission case, we use the small arbor and the soft hammer to install the selector arm shaft oil seal into the transmission case. The selector arm is inserted from the trapdoor side of the transmission case. We must be careful not to push the oil seal out as we are pushing the selector arm shaft through its bushing. We avoid this by applying some assembly lube to the selector arm shaft. Once we've pushed the selector assembly home, we slip on the retaining washer, Sputh part number 8322, and using a small pair of offset circlip pliers, we replace the new circlip, Sputh part number 8331, on the selector arm shaft to lock the whole selector assembly in position. You must still be wearing your safety glasses before installing the main drive gear. We must insert the main bearing retaining circlip. Remember that the bevel on the circlip faces away from the bearing. Next, we quickly check that the main bearing is seated correctly in the housing and is not obstructing the circlip groove. Using a large set of offset circlip pliers, making sure we have the circlip securely on the jaws of our pliers, we insert the large circlip into the transmission case. We place the oil seal on the drain plug and replace the drain plug in the transmission using a 7/8" box wrench, torquing it to 7 foot-pounds. As a safety precaution, we retorque the drain plug after the complete transmission is inserted back into the frame. We bring the chain drive main gear in from the trapdoor side of the transmission and push it squarely into the main shaft bearing. Only after the bearing circlip has been installed should we begin our next procedure. Taking a solid piece of timber and our soft hammer, we firmly hammer the main drive gear into the main shaft bearing until the shoulder of the main drive gear is firmly up against the main shaft bearing. We also check that the main drive gear will rotate freely. We use compressed air to blow any debris or wood particles out of and away from the main shaft bearing and the transmission case. The oil seal, part number 8249 for the main shaft bearing, is placed squarely over the main drive bearing, the open end of the seal to face towards the transmission case. Using the soft hammer, we gently tap the main shaft oil seal in evenly until it's flush with the transmission case. Taking the spacer, we smear it with a film of oil so that it will not damage the main drive gear oil seal. Be very careful. If we damage this seal, it will leak as soon as you put oil in the transmission. If you are rebuilding a late model 1993 stock 5-speed transmission, your stock oil seal part number is 8249, which happens to be slightly larger than the Sputh seal. The procedure for its installation is exactly the same for the Sputh transmission, including tapping the seal several times with the soft hammer until it's flush with the case. We slide the O-ring, part number 12050, over the belt drive main gear, making sure that it slips past the outer edge of the oil seal. The spacer, part number 33334-85, will have a bevel on its inside edge. We smear the spacer with oil and slide it over the main drive gear, making sure that the bevel is facing towards the main shaft bearing, being very careful not to damage the main drive oil seal. Insert the tapered ends of these two new locating dowels for the trapdoor assembly into the transmission case. Again, using our soft hammer, we tap each dowel in until it bottoms out into its respective hole. Do not reuse dowel pins from the previous teardown. First, we double-check that both the main shaft and lay shaft gear clusters are assembled correctly and that they will mesh together. Moving both shafts to the trapdoor, we insert each shaft through its respective bearing, helping the individual gears mesh with their counterpart. On the clutch side of the trapdoor, we then place a pair of 3/4 inch by 16 UNF nuts on each shaft, using a 3/4 inch socket and ratchet. We tighten each nut alternately until each shaft is pulled up against the trapdoor bearing. Do not attempt to draw these shafts completely into their bearings just yet. We only want these nuts to be firm at this stage. Lifting the whole trapdoor assembly, we insert the main shaft through the main bearing. Locating the trapdoor on its locating dowels, we rotate the gears on the main shaft so that they will align with those on the lay shaft. Next, we lock the shafts by sliding these gears across like so, with both shafts locked. We continue to tighten these nuts alternately, drawing both the main shaft and the lay shaft into their respective trapdoor bearings until we can no longer turn either nut. We now back off and remove the old nuts and place a spacer, Sputh part number 8274, stock part number 35076-79 on each shaft. Note the ring of nylon in our new size 3/4 by 16 Nylex nuts. This nylon ring will prevent these nuts from vibrating loose while the transmission is in use and can only be used once. We torque these nuts to 27 to 33 foot-pounds. Taking our new trapdoor gasket, we place it on the tranny and check to make sure it is the correct shape and that all the holes and dowel pins line up. Once we're satisfied that the gasket is correct, we clean all metal gasket surfaces with an acrylic thinner to remove any dirt and grease. To ensure a positive seal with our trapdoor gasket, we lightly paint both the gasket and the trapdoor gasket surface with gasket cinch and place both painted surfaces together, making sure that all the holes are aligned properly up against the case. Dipping our acid brush in assembly lube, we coat both main shaft needle bearings in the main drive gear, 5th, and the lay shaft bearing. We use our finger to force the assembly lube to penetrate completely into both main shaft bearings and the lay shaft bearing. Taking the complete trapdoor assembly, we once again gently insert the main shaft through the main drive gear and also inserting the lay shaft into the lay shaft bearing. By slowly rotating the main shaft, we allow all the gears to align and mesh with one another, allowing us to locate the trapdoor on the two locating dowels. After checking that the lay shaft has entered the lay shaft bearing, we take our soft hammer and gently tap the trapdoor home while rotating the main shaft to allow the gears to mesh with one another. Once the trapdoor is firmly up against the transmission case, we take our 4 5/16 inch by 18 UNC cap screws and our 2 1/4 inch by 20 UNC cap screws. The 4 5/16 inch by 18 UNC cap screws are inserted along the base of the trapdoor, and the 2 1/4 inch by 20 UNC cap screws are inserted in the top of the trapdoor like so. Using a 5/16 inch Allen wrench and a 1/4 inch Allen wrench, we nip these cap screws up. Using an inch-pounds torque wrench, we torque the 5/16 inch cap screws to 200 inch-pounds and the 1/4 inch screws to 100 inch-pounds. This shifter fork, Sputh part number 8378, is responsible for giving us first and second gears. This shifter fork, Sputh number 8379, will give us third and fifth gears. And the center fork, Sputh part number 8380, will give us fourth gear. The shifter fork fits into the groove on a gear like this and slides its gear back and forth along its respective shaft to mate it with different gears to give us different gear ratios. The shifter fork tolerances are shifter fork to gear groove end play, 1 thou to 11 thousandths of an inch. Shifter fork taper, 0 inches to 20 thousandths of an inch. The shifter fork responsible for fourth gear slides onto the first gear on the main shaft. The shifter fork responsible for first and second gears slides into the groove on third gear on the lay shaft. The shifter fork responsible for third and fifth gears slides into the groove on second gear on the main shaft. Turning to the primary side of the transmission, we take the 1/2 inch by 20 UNC selector shaft plug and seal the threads with Teflon tape to prevent any oil leaks and the plug from vibrating loose during operation. Note we wrap the Teflon on in a counterclockwise direction. Using a 1/4 inch Allen wrench, we take the plug down until it is flush with the outside of the transmission case. With the plug in place, we take the selector shaft and insert the shaft through this port in the top of the trap door. We then lift the shifter forks so that we can feed the selector shaft through each shifter fork and into the primary side of the transmission to butt up against the plug. Turning our attention to the top of the transmission, we take 2 split locating dowels, Sputh part number 8204, stock part number 609. We make sure that the tapered edge of the locating dowels face in toward the cap screw holes. Using our soft hammer, we gently tap them into the counterboard cap screw holes for the pillar block with the detent pin, being careful not to force these dowels in past their recesses and into the internal threads of the cap screw holes. Next, we check the top cover gasket, Sputh number 8270, for shape and hole alignment. Using a clean rag soaked in acrylic thinners, we clean the gasket surface, removing all traces of grease and dirt. With our acid brush, we paint the gasket and the top cover gasket surface with gasket cinch, being careful not to get any excess gasket cinch in any of the bolt holes. We then place the top cover gasket in position, aligning all cap screw holes and pressing the gasket firmly to the case. Now to the shift drum itself. Here we have marked the cams for the respected gear positions. Yellow is first. Between first and second is neutral. Blue is second. Black is third. Red is fourth. White is fifth. We check that the detent pin will move freely back and forth in its pillar block housing. We line the detent pin up with the third gear cam. We partially slide the pillar block onto the shifter drum. Depressing and locking the detent pin into the third gear cam marked black, between second gear blue and fourth gear red, and slide the whole pillar block firmly up against the shifter drum. To install the shifter drum assembly, we must first locate the recesses machined into the mounting holes of the pillar block. The recesses in the pillar block here have to locate directly onto the 2 locating dowels on top of the transmission case that we have previously installed. Lifting the selector paw out of the way, we lift the shifter drum up and the pillar block onto its locating dowels. We gently release the selector paw onto the shifter drum pins. We must move the shifter dogs so that they sit securely in their respective grooves on the shifter drum. Holding the end of the shifter drum up, we slip the second pillar block into place. This wide groove is for the neutral switch. Taking 4 1/4 inch by 20 UNC cap screws and a 3/16 inch Allen wrench, we bolt down the pillar blocks. The torque setting is 75 inch-pounds for all 1/4 inch pillar block cap screws. To measure the end float of the shifter drum, we gently push the shifter drum firmly up against the pillar block with the detent pin. With a set of dial verniers, we measure from the trapdoor side of this groove to the machined surface on the trapdoor side of this pillar block. Holding the dial verniers level, we place the jaws squarely against the trapdoor edge of the groove and the machined surface on the pillar block. The distance should be 1.992 inches, as is this measurement. If the measurement is under 1.992 inches, we must shim inside the pillar block. Now we place a shim, part number 33205-80, on the shifter drum shaft, followed by a circlip, sputh part number 8337, stock part number 11083, using the circlip pliers to push home the circlip into its groove. Once the circlip is in place, we gently slide the shifter drum in the opposite direction until it's firmly up against the primary side pillar block. Then we measure the distance between the same 2 points on the shifter drum with our dial vernia, making sure the vernia jaw is on the machine pillar surface, not the washer. This length should be 2 2/2 inches, giving us a tolerance of 10 thou for the end float. We have now moved to the primary side of our transmission. This is the adjusting screw for the selector arm mechanism. Notice it has a pin at one end which has been machined off-center. This is called an eccentric pin. The eccentric pin is inserted into the transmission. As we screw the adjuster in, we must line up the slot in the selector arm plate with the eccentric pin as it comes through the transmission case. Here we see the eccentric pin engage and move the whole selector arm mechanism back and forth. We do not run the threads of the adjuster screw past the inside of the transmission case. The position of the eccentric pin controls the gap here between the shifter paw and the shifter drum pins. The shifter paw should be centered on the shifter drum pins. Each gap should be approximately 3/64 of an inch. This measurement must be equal to within 10 thou. We place a 7/32 inch Allen wrench in the selector arm adjuster screw. We then take a 3/64 inch Allen wrench to check the gaps between the shifter paw and the shifter drum pins. Once we've set an equal gap on both sides of the shifter pin, we use an 11/16 inch open-ended wrench and tighten the lock nut to lock the selector arm assembly into position. We then recheck the gap between the paw and the pins to see if the paw is moved while we lock down the selector screw lock nut. When the shifter paw gap is correct, we replace the top cover. We clean the top cover gasket surface and place it on the top of the transmission, and then replace the 5/4 inch by 20 UNC cap screws with a 3/16 inch Allen wrench, and then torque them to 75 inch-pounds. Before assembling the linear bearing, we apply some assembly lube to the clutch rod. The first thrust washer, sputh part number 8127, stock part number 37313-80, slides up against the clutch rod. Next, we slide the linear bearing, sputh part number 8126, onto the clutch rod. Notice how the needle bearings radiate from the center. The linear bearing is placed firmly up against the first thrust washer. Again, apply assembly lube. Now the second thrust washer. We make sure that the second thrust washer is hard up against the linear bearing and that the linear bearing will rotate. Taking one snap ring, sputh part number 8105, stock part number 11096, using a pair of needle pliers, we insert the snap ring onto the groove at the end of the clutch rod assembly. You must be wearing your safety glasses when you install this small snap ring. Here are all the tools and components we need to assemble the ball and ramp mechanism. First, we take the base plate, sputh part number 8254, and insert it into the ball and ramp housing with the tongue of the base plate sitting in the slot. Next, we place 3/4 inch diameter ball bearings on the base plate, but first we apply some assembly lube to the 3 ramps on the base plate. The assembly lube will hold the 3 balls in position so that we install the top plate, sputh part number 8253, stock part number 25452-87. The 3 ramps on the top plate must line up with the 3 ball bearings on the base plate. Taking the circlip, sputh part number 8240, stock part number 10998, and a pair of offset circlip pliers, we insert the circlip into the recess above the top plate. Lastly, we replace the dipstick in the ball and ramp housing with a 5/16" Allen wrench. The dipstick must clear the ball and ramp mechanism, and of course, we've replaced the O-ring on the dipstick. Before we replace the ball and ramp gasket, Sputh part number 8280, stock part number 36801-87, we must clean the gasket surface and check that the hole position and shape of the ball and ramp gasket is correct. With our acid brush, we apply gasket cinch to the gasket surface on the trap door and to the corresponding mating surface of the ball and ramp gasket. We place the ball and ramp gasket on the trap door, making sure we align all the mounting holes and that the ball and ramp gasket is flat against the trap door surface with the gasket sealant at all points around the gasket. Next, we apply some assembly lube to the clutch rod assembly shaft and insert it into the center of the main shaft. Now we place the ball and ramp housing over the trap door with the head of the dipstick to face to the top of the transmission. We replace the 6/4" by 20 UNC mounting cap screws and nip them up with a 3/16" Allen wrench. We torque the cap screws to 75 inch-pounds. When the transmission is in neutral, fifth gear will not rotate with the main shaft. We've placed the selector arm on the selector shaft so that we can move the transmission up and down the gears. By rotating the main shaft, we allow the gears to mesh and change position as we change gears. We start with the shifter drum in neutral. Then we go down to first. Its ratio is 2.94 to 1. Back up to neutral. Up to second. The second gear ratio is 2.21 to 1. Up to third, its ratio is 1.6 to 1. Up to fourth, its ratio 1.23 to 1. Up to fifth, its ratio is 1 to 1. Now we must go back down through the gears and check that the shifter fork dogs are sliding freely in the grooves on the shifter drum. See how the shifter forks operate. By following the grooves in the shifter drum, the shifter forks are forced to slide back and forth along the selector fork shaft, disengaging and engaging gears as they go. Our transmission has passed the test and shifts up and down through all 5 gears in neutral. It's now ready to be installed into our frame. Here are all the tools and components we need to replace the clutch cable. Placing the small O-ring on the end of our cable, we slip the cable into the ball and ramp housing and screw the cable all the way into the ball and ramp housing. Using a 9/16" open-end wrench, we secure the lock nut on the clutch cable. Taking the clutch cable coupling, we insert the nipple at the end of the clutch cable into the coupling. The head of the coupling slides into the slot on the tail of the top plate for the ball and ramp. We face the head of the coupling to the inside of the top plate. Now we replace the top plate, making sure the ramps on the top plate are seated squarely on the ball bearings on the base plate. Next, we insert the retaining circlip and test the ball and ramp assembly. When we pull the clutch cable, the top plate of the ball and ramp assembly rises on the ball bearing and presses up against the clutch operating rod and disengages the clutch. That completes the teardown and rebuilding of a 5-speed forward constant mesh transmission in a Sputh case designed to mount into your pre-1980 Harley 4-speed frame. The assembly of your stock 5-speed transmission is exactly the same as you've just seen, with the exception of grinding your lay shaft. We at Video Manuals wish to gratefully acknowledge and thank Mr. Alan Sputh and his wonderful crew for allowing us to use their facility and products in providing the technical information used in this video.